Okay, this will be the last video for the series of videos with the goal to be seeing if you're ready for Math 104. And we have the integral from 3 to b of 3x squared dx being equal to 37. This function from 3 to some value b has the following look to it. And the area under the curve is equal to 37. This is f of x being equal to 3x squared. And it's our job to find b. Okay. The fundamental theorem of calculus says that you take the function that's on the inside and you find its antiderivative. The power rule in reverse would be us taking the 3, leaving it alone, adding 1 to the exponent, dividing by the same thing. The function has 3x squared as its derivative is x cubed. That's your antiderivative. You take that antiderivative and you evaluate it at your endpoints. And that'll be the value of your area. Fundamental theorem of calculus. B cubed minus 27 is 37. The set area. And so we add over the 27 and we get the fact that b cubed is a convenient value 64, making b being the guy that you cube to get a 64 4. Now we have x cubed plus 1, who is squared in the denominator, and x squared in the numerator. This is your classic inside function who has pretty much, not exactly, but its derivative as the rest of it. We'll say almost the derivative of the inside function. In this case, we're doing the chain rule. This is sort of anti-chain rule. Chain rule in reverse. This is a composite function. I'm on to let, it's called u-subtitution. Let u be that inside function. Its derivative, called du, is 3x squared dx. And so I divide by 3 because I need to replace x squared dx in my substitution, and I can do that by 1/3 times du. My integral will become the x squared dx becomes 1/3 of du. The x cubed plus 1 whole thing squared becomes u squared. The integral, who has 0, 1 x limits, we can change those to have u limits. It's called a limit switch. Take the x numbers, 1 and 0, plug them into the formula to get the u numbers. So 1 cubed plus 1 would be a 2, and 0 plus 1 would be a 1. So our new limits on u would be 1 and 2. And now it's a much simpler integral. Pull out the 1/3 and bring that 2 up with a negative exponent. Negative exponents are great to take the antiderivative and the derivative, not so good as comes time to evaluating. Antiderivative would be a power rule in reverse here. U to the -1 over -1, adding 1 to the exponent. We have this 1/3, and that's going to be better simplified as -1 over 3u. For algebra's sake, we're going to go back to positive exponents. And so we want to plug in a 2 and plug in a 1. We'll have -1 over 6 and minus a -1 over 3. Or -1/6 plus a third. -1/6 plus 2/6. The answer is 1/6. Okay, that's the total area there with the limit switch. All right, and the final question, question number 20. E to the kx, the antiderivative of that, would be 1 over k e to the kx plus a constant. So if you have some multiplier on x up in the exponent of e, you have to take its reciprocal. It's kind of like a skipping a chain rule. Essentially, if you let u be kx, the same kind of thing we just did, we'd have k dx, and we have 1 over k du replacing dx. And so there's this 1 over k that comes in. Anyway, and then so we are trying to integrate e to the 2x and then later x cubed, and we accomplish that by taking the antiderivative of the first guy, getting a half e to the 2x, antiderivative of the second guy, getting x fourth over 4, and then it's our job to do the limits of 0 and 3. Fundamental theorem of calculus says you can just plug those guys in and be done. Take e to the 6th and take 3 to the 4th over 4. Plug in a 0, we get e to the 0 plus a 0. And we end up with half of e to the 6th and 81 over 4 minus a half, because e to the 0 is a 1. And so that's 81 over 4 minus 2 over 4. So 81 minus 2 all over 4. And that'll be a 79 over 4. Half of e to the 6th plus 79 over 4. Okay, great. So this ends the series of videos going through 20 problems from Math 103, or just first semester calculus, and we need to be able to do all these types of problems before even starting Math 104. In Math 104, we pick up from here and we do applications of integration, volume, arc length, surface area. We do techniques of integration. We want to be able to integrate more functions, so we do integration by parts and trig substitution, partial fractions. We dip back into applications, probability and improper integrals, and then we do differential equations, trying to solve a derivative equation with a derivative in it. And then the major part at the end of Math 104 is sequences and series. More series. Only one section on sequences. They're the underpinnings of series. And that's it. Okay, great.